some mathematical functions are pretty weird to deal with. Why am I using this word weird? That's because, at times in functions, you do not have explicitly given functions. You don't have a particular fx equals to y sort of a thing. Okay. Then how does the differentiation works? Then there is a special case of chain rule which we apply, and that's called implicit differentiation. For example, let us just quickly take a unit circle. A unit circle has an equation as the following. Okay, x square plus y square equals to 1. 1 is the radius of this function. Now, if I want to differentiate this function, this equation, how do I differentiate this equation? I can just simply, with respect to x, I can just simply take d by dx of this equation, right? D by dx of this equation, separating all the parts, what I get, that d by dx of x square plus d by dx of y square plus equals to d by dx of 1, right? And as a result, what will it give me? It will give me 2x for d by dx, x square. It will give me 2y into dy by dx, which will equal to 0, because d by dx of 1 will be 0. Correct? So this is how it will look like. This is how it will look like. So 2x plus 2y dy by dx, okay, equals to 0, because we are differentiating with respect to x. So once we have differentiated y, y needs to be differentiated with respect to x, okay, and that is how I can find out my dy by dx. Dy by dx will simply be, taking this to this side. So minus 2x upon 2y, that will give me minus x by y. See, that's my dy by dx. So I've tried to figure it out. We have differentiated normally, okay, we have differentiated the way we could. We have differentiated the whole equation, okay, keeping in mind that, I don't have an explicit function of y of x, okay. I am not given an explicit function y equals to fx, so hence I am differentiating y with respect to x when I am differentiating y square, okay. Now, there's another way of doing it. The other way would be probably, if I'm not given the function explicitly, why don't I make it explicit? If I'm not given the function explicitly, why can't I make it explicit? So, I had x square plus y square equals to 1, which means y square equals to 1 minus x square. Taking the positive square root, I get under root 1 minus x square as my y. So now looking at y prime, or differentiating y with respect to x, will give me as following. Okay, how do I get this? Now this is essentially, okay, I'll just give you a brief of that also. Now y equals to 1 minus x square to the power positive half. Okay, so this makes it half 1 minus x square minus half, because this will be essentially half minus 1, okay, which is minus half. Now I will have to use the chain rule because I have x square inside, right? So into minus 2x, minus 2x is inside. 1 leads me to the differential 0, so 0 minus 2x. Okay, so that's how I get down here. So comparing with the explicit differentiation, what do I get? As I said, I get this, okay. This, we have written this directly, but this is essentially derived the way I just showed you. This is essentially derived the way I just showed you. So here it is, okay. Comparing it with the previous differentiation, the implicit differentiation. So we found out our derivative implicitly here. We found out our derivative implicitly here. Now we found out that it is equal to minus x upon, let me just change my color, minus x upon y, and y is nothing but 1 minus x square, and that's what we have been getting. So the result would be same of implicit and explicit, but there are at times functions which you just can't imagine explicitly. You know, you have functions which are implicit only, then you need to use implicit differentiation in order to solve them.